Good morning, students. This is a lecture series on digital system testing and testable design, Module 1. I'm Seema Safar, Assistant Professor, Department of Computer Science and Engineering, Rajagiri School of Engineering and Technology. We'll start the session. Module 1 of this subject consists of two parts. The first part discusses about fundamentals of testing, and the second part is about modeling. Now, the fundamentals of testing includes testing and diagnosis, testing at different levels of abstraction, errors and faults, modeling and evaluation, types of testing, and test generation. And the second part of this module includes different modeling techniques like functional modeling at logic level, functional modeling at register level, and structural models. In this series, we'll be discussing on the first part of Module 1. Let's start with the fundamentals of testing. The first topic in fundamental of testing is testing and diagnosis. So what is testing? What do you mean by testing of a system? Testing of a system is an experiment in which the system is exercised and its resulting response is analyzed to ascertain whether it behaved correctly, which means if it responded as we expected. If an incorrect behavior is detected, the main goal of a testing experiment is to diagnose and to locate the cause of the misbehavior. Now let's discuss about testing at different levels of abstraction. Always the complexity of a circuit is related to the level of abstraction required to describe its operation in a meaningful way. Now, although a digital circuit can be viewed as processing analog quantities like voltages and current, the lowest level of abstraction is always called as logic level. Now, the information processed at this level is represented either by 0 or 1, which means it is represented by discrete logic values. Now, the classical representation uses a binary logic value 0 and 1. Now, this figure will be depicting what are the different types or the levels of abstraction of testing. Testing can be either at logic level, where the control and the data includes logic values. Now, testing can be either register level, where the control and the data differs when compared to logic level, because logic values will be in the control and data will be in the form of words. Whereas in instruction level of abstraction, the control will be in the form of instructions and data will be in the form of words. Now, the fourth level is the processor level, where the control is in the form of programs and data is in the form of data structures. Now, the outermost layer, which is called as the system level, includes control in the form of messages and data in the form of messages. Now, this figure depicts the level of abstraction in information processing by a digital system. Now, let's discuss about errors and faults in digital systems. Usually, what do we mean as an error? An error is basically an incorrect operation that is happening in a system, right? Again, the concept of the error can have different meanings at different levels. For example, an error which is observed at the diagnostic programming level, it may appear as an incorrect result of an arithmetic operation. Now, the causes of observed errors may be design errors, fabrication errors, or fabrication defects, or it can be either physical failures. Now let's move on to the example of design errors. Design errors are incomplete. It can be either incomplete or inconsistent specifications, or it can be incorrect mapping between different levels of design, or it can be a violation of design rules. Now, the errors occurring during fabrication include wrong components being connected, or it can be either incorrect wiring of the system, or shorts which is caused by improper soldering. Fabrication defects are not directly attributable to a human error. Now, they actually happen from an imperfect manufacturing process. For example, shorts and opens are the common defects that is happening in manufacturing most large scale integrated circuits. Now, other fabrication defects include improper mask alignment errors and poor encapsulation errors, etc. Physical failures occur during the lifetime of a system due to component wear and tear. For example, the aluminum connectors inside an IC package usually thin out with time, and it may break because of electron migration or corrosion. Now, there are other environmental factors which causes this, such as temperature, humidity, and vibration, which causes the aging of components. Moving to another fundamental of testing, which is modeling and evaluation. First, we'll discuss about modeling. Basically, as design errors precede the fabrication of system, design verification testing can be performed by a testing experiment which makes use of a model of the designed system. So in this context, model means a digital computer representation of the system in terms of data structures or programs. Now, model can be worked by simulating it with a representation of input signals. This process is referred to as logic simulation, which we'll be discussing in the coming slides, in the coming sessions. Now, another important concept is test evaluation or simply evaluation. Now, another important problem in testing is test evaluation. Now, test evaluation refers to determine the effectiveness or the quality of a test. It is usually done in the context of a fault model, and the quality of a test is measured by the ratio between the number of fault it detects and the total number of fault in the assumed fault universe. This ratio is usually referred to as fault coverage. Test evaluation is carried out via a simulated testing experiment called fault simulation. We'll be studying fault coverage and fault simulation in the coming modules. Now let's discuss about different types of testing. The first one is in-circuit emulation. In in-circuit emulation, it eliminates the need for a hardcore in running diagnostic programs. Now this method is used in testing microprocessor-based boards and systems. And it is based on removing microprocessor on the board during testing and accessing the microprocessor connections with the rest of the UUT from an external tester. Next, we have online testing. In online testing, the stimuli and the response of the system are not known in advance because the stimuli are provided by the patterns which is received during the normal mode of operation. Then we have the third type, which is guided probe testing, which is a technique which is used in board level testing. If errors are detected during the initial edge pin testing, the tester decides which internal line should be monitored and instructs the operator to place a probe on the selected line. Then that test is reapplied. The principle is to trace back the propagation of errors along the path through the circuit. That is guided prop testing. So it is a sequential diagnosis procedure in which a subset of the internal accessible lines is monitored at each step. Then we have an algorithmic testing, which refers to generation of the input patterns during testing. Counters and feedback shift registers are typical examples of hardware which is used to generate input stimuli. Algorithmic pattern generation is a capability of some testers to produce combinations of several fixed patterns. The desired combination is determined by a control program written in a tester-oriented language. Now, the last topic of the first section is test generation. What do you mean by test generation? Now, it is a process of determining the stimuli necessary to test a digital system. It depends mainly on the testing methods that is being used. Online testing methods do not require test generation. Now, little test generation effort is required when the input patterns are provided by a feedback shift register working as a pseudo random sequence generator. Test generators can be either fault oriented or function oriented. In fault oriented test generators, one tries to generate tests that will detect specific faults. In function oriented test generators, one tries to generate a test that, if it passes, shows that the system performs its specified function. This we'll be seeing in the coming modules in future. Let's wind up our session with a quick summary of the session. So far, we have discussed about testing and diagnosis in digital system. Then we discussed about different levels of abstraction like logical level, register level, instruction level, and so on. Then we discussed on the terminologies, errors and faults in digital systems. After that, modeling and evaluation. Then different types of testing. We discussed around 4 categories of testing. And finally, test generation in digital systems. The reference textbook for this session is listed here. Thank you.